Today, our group will be covering various aspects of PolyJet printing.
To introduce our team, my name is Anna Demonaway. I'm an industrial engineer, senior three, and I work at Lear.
My name is Sam Kneebone. I'm an industrial engineer as well, junior two, and I work at Dow Chemical.
My name is Justin Miller. I'm an industrial engineer, junior one, and I co-op with Ford.
My name is Arriana Porter. I'm industrial engineer, junior one, and I co-op at General Motors.
My name is Lauryn. I'm also an industrial engineer, senior three, and I work at Lear Corporation.
My name is Magdalena, senior three, industrial engineering major, and I co-op at Forvia.
So, what is PolyJet printing? So, similar to a regular inkjet printer, instead of ink on paper, it prints layer upon layer of photopolymers on a build tray up to zero point 0.1 millimeters of accuracy. And here's a video.
Once the material is loaded in the 3D printer and digital instructions are programmed, production begins as the jetting head rapidly moves along the x-axis, the y-axis, and the z-axis. Small droplets are sprayed by photopolymer jets in layers that are instantly cured by an ultraviolet lamp. Voxels, or three-dimensional pixels, are strategically placed during the build to allow for the combination.
Okay, next we're going to get into some history of PolyJet printing. So, PolyJet printing background. PolyJet printing, also known as polymer jetting, is a 3D printing technology. This is based on material jetting and allows for full and multicolor 3D printing. This can print multiple materials at the same time, which is one of its unique features, and also is one of the most accurate 3D printing technologies with accuracy up to 16 microns. It creates a smooth finish on its products. And then some history of PolyJet printing. So it was developed in 1998 in Israel, and the company was Objet Geometries. This is a 3D printing manufacturer in Israel. Some history is that successful venture, $15 million investment in 2000, company valued at 36 million in 2000, and merged with Stratasys 3D printing company in 2012 to market better together. A PolyJet printing machine costs around $6,000 to $75,000, and PolyJet versus material jetting. Patent name for polyjetting versus material jetting.
So this is the printing process. So for step one, you're going to want to import CAD file into the PolyJet 3D printing software. From there, you arrange the printing order. You select your material needed and determine the size, colors, and support structures. Step two, the printing phase. So small nozzle deposit drops of liquid photopolymers onto the build tray. Then material is cured by UV light as it is deposited. The third step is polymers are heated between 30 to 60 degrees Celsius, and supports are needed during the printing process to prevent deformation. Step three of this is the support removal. So you remove gel-like support structures by hand or using water. Usually no other processes are needed. The step four, post-process. Sanding, you can sand the part, and then the part can also be dyed or painted.
Materials used in PolyJet, materials have to have like a low viscosity. There are 8 types of materials that PolyJet offers. Digital materials, digital ABS plastics, which are stronger and more heat resistant than regular ABS plastics. Rubber-like materials, high temperature materials, transparent materials, rigid opaque materials, simulated polypropylene materials, and biocompatible materials.
Next, we'll look at the advantages and disadvantages of PolyJet printing. So some of the advantages is that it's one of the fastest 3D printing technologies. What makes it the fastest is that it can print in a line compared to printing from a fixed point. It also deposits liquid resins rather than extruding the model from solid materials. Another advantage is that there are expanded color and material options, allowing for a wide range of printing options. It also prints very accurately. So this would be like smooth surface finishes, true to life textures, complex shapes, intricate details, and delicate features. There's also little deformation, so minimal defects occur with PolyJet printing, and then the material quickly cures, and there's a supported removal process. Next, looking at some of the disadvantages. PolyJet printing is weaker than other 3D printing methods. Also, larger parts are less accurate and they shrink when curing. The process can also be expensive, and then long-term exposure to heat, sunlight, and humidity can cause warpage and loss of strength.
Other considerations for the designing process, anyone with CAD experience can design a part. It's also compatible with any CAD software, and you can print multiple materials and colors with one product. Economic, rapid growth in the industry, which creates multiple opportunities in the economy. Financial savings for companies that invest in PolyJet printers. Environmental considerations. PolyJet printing. Liquid PolyJet material is more toxic material than other types of plastic. It's also non-recyclable and high waste.
Next, we'll look into some industry case studies and applications. So there are many industry uses for PolyJet printing. The first of which is in automotive. So automotive can use PolyJet printing for prototyping interior and exterior components, engine parts, etc. The medical industry also utilizes it. Hospitals can print customized anatomical models that they can use to help explain their surgeries and procedures to a patient so the patient can better understand what they will be going through. And then consumer goods. PolyJet printing can create fully functional and realistic prototypes and also aid in packaging design. And then it can also be used in the art, design, and fashion industries since it's able to print very detailed pieces. It can be used for clothing, shoes, and accessories. And then other industries include aerospace and dental.
So we have a couple automotive case studies that we found relating to PolyJet printing. The first is with Bentley Motors containing flexible optimized design prototyping. So Bentley Motors prints every detail of future production using PolyJet printing, and this allows them to test multiple designs, bringing them closer to the final product much more quickly. Next is with Audi. So Audi accelerates automotive design. PolyJet technology upgraded Audi's ability to prototype, allowing them to be more selective in which parts they use in their designs. And it also allowed for it created the capability to extend production of parts, including wheel covers, grills, door handles, and rear light cabs. And then lastly, it generally sped up the process of design and development, allowing them to meet higher customer demand. Next is Volkswagen. Volkswagen utilizes PolyJet printing to create ultra-realistic prototypes for interior and exterior applications. PolyJet printing is enabling Volkswagen to be more innovative with new vehicle designs, and investing in PolyJet printing allows the design team to meet quality requirements and create complex multi-material prototypes, replicate final production parts with 99% precision, and improves testing processes and overall part designs. Last is the McLaren F1 team. Stratasys has been working with McLaren Racing to significantly increase the usage of additive manufacturing and 3D printing, such as PolyJet printing for the use of prototyping, tooling, and end-use products for the McLaren Honda Formula One team. Stratasys will be the official supplier of 3D printing solutions to the F1 team. Stratasys has also been signed to work with the Grand Prix team at the McLaren Technology Center, where the partners will implement fused deposition modeling and PolyJet technologies to 3D print visual and functional prototypes, as well as production composite tooling and custom production parts. These parts will be designed specifically to increase the performance of the F1 cars while also ensuring quick delivery via additive manufacturing.
So now we're going to look at how PolyJet compares to other technologies in the industry. So when we compare PolyJet to fused deposition modeling, or FDM, they're similar because they both build the model layer by layer on a printing bed. However, they have a lot of differences. PolyJet printing uses liquid photopolymers, while fused FDM uses heated thermoplastic filaments. PolyJet printing has a more variety of material applications, and fused deposition modeling has a limited variety. During printing, PolyJet prints in a liquid state, and fused deposition modeling prints in a semi-solid state. So because of that reason, PolyJet printing has more flexibility and detail, and fused deposition modeling is sturdier and more durable since it's in a solid state. PolyJet printing cures in a UV light, and fused deposition modeling cools and solidifies, so it takes longer. And it's limited because PolyJet printing is less durable because it has flexibility, and fused deposition modeling is not as flexible or detailed because it's in a solid state. When comparing it to stereolithography, or SLA, they both use liquid resin that turns solid when exposed to UV light. They're different because PolyJet deposits resin onto a build plate from bottom up, and stereolithography extrudes the object out of a pool of resin upside down. PolyJet printing can print more than one object, and SLA can only print one at a time. And they have a huge difference in support removal. PolyJet printing, you can just remove it by hand or water, so you don't have to contact any hazardous resin, and it's super fast. And SLA, you have to remove the supports with sandblasting or alcohol baths. In conclusion, we believe that this is a very good technology to use for prototyping due to its ability to accurately print details, its quick printing, and how much of a low cost it is to print. It has a lot of printing capabilities, like printing multiple materials and colors on one model, and its easy and safe support removal is a very huge benefit since normally that is a very time-consuming process. 100% of our teammates are happy with this technology. These are the references that we used. We used 3 main general PolyJet ones and 3 case studies.
Okay, so just getting into some co-op experience that this project made me think of as we were going through it. So my co-op at Lear Corporation, we have a 3D printer. It's not a PolyJet printer, but it's just a traditional 3D printer. And I've seen this used quite often throughout day to day when just you need a quick part made or a tool made. More likely, it's been used for tools. So, for example, there was a time last term that we were 3D printing headrest guides, a tool to help operators put headrests into the vehicle. And we were only able to print about 3 guides a day just due to the lengthy process that the traditional 3D printer took, as well as just the capacity that it could print at one time. So this just could be an area where PolyJet printing could be more beneficial, could print more parts, and also since it is a faster process, I could just see benefit being added in this area.
Although this is not a co-op experience, I have a friend who's working on his master's in human factors, and he was looking into PolyJet printing for like arm casts and arm supports, and he was telling me about how like it's super flexible and the material is really easy to use. So he's gone through a few prototypes for his master's program that has really advanced this field of PolyJet printing. So that is a very cool story.
All right. So thank you for listening in on this presentation. And if you have any questions that you'd like to ask about PolyJet printing to our group, we would be more than happy to answer them. Thank you very much.